So, run of the river or diversion is one of the great concepts in current available power production. And this is actually the one that we use up near Love Canal in Niagara Falls. So Niagara Falls has a hydropower plant. It's on the Canadian side of the border, but we do provide power over the border into the United States. And we use a diversion system because we don't want to reduce the amount of water that's going to flow over those falls. We want to keep those falls beautiful. So diversion was really the way to go. And we can produce huge amounts of power. It works the same way where I have a gate and I raise and lower my gate based on the amount of water that I want flowing down my penstock, and I allow it to fall through my penstock, and the outlet is actually right here on this system. Which brings me to small scale. So this is a form of diversion that is known as pump storage. And pump storage is kind of my third concept. It's small scale, and it can be done on a river where I have a change in elevation or a curve on that, or I can just use energy to pump up water into a holding pool above. And then when I need power, I can open up, once again, my gate on my penstock and allow it to flow down the system to produce electricity as needed. And so this is a home-built generator system. This is done for a small farm out in Vermont, and this is one of my old college professors. This is the fabulous Dr. Michelle Lukey, and this is a pump storage module where the water was pumped up higher, up above this system, and it's dropped down based on demand. So we open up it's actually, on this case, it's just a knob. So we're just turning the tap, right? So I'm just turning the tap and turning on the water, and I allow the water to flow down, and then it flows through my turbine and drops down through the system, and the generator's right on top of the turbine structure here. You can see it there in the blue. Let me move my little cursor here so you can see it here in the blue, right? So simple structure. So pump storage is something that the Army Corps of Engineers uses all the time for on-demand power in places where water is something that's highly available, but I need to build remote power in a area. So it's something that we utilize often, and it's something that is becoming more and more popular. I am seeing it a lot in Vermont and New Hampshire, where you have an area where you have a water supply that you could pump a little bit off of your water supply and build a structure like this to provide your power needs. Here is the artist rendition from your text. And this brings me to categorizing hydropower. So we've talked about how hydropower is something that is regulated. So these dam structures are something that is regulated highly within the United States. And there are actually 3 categories of hydropower in the U.S., 2 of which are regulated, 1 of which is not. And that one that is not regulated is the one that I'm seeing done in places like Vermont, New Hampshire, on things like small cow farms, where they want to build remote power out in the paddy in the back to be able to do some function out there. And so large-scale hydropower facilities are facilities that are producing more than 30 megawatts annually. So this is yearly. So the Department of Energy, DOE, defines large hydropower systems as being anything over 30 megawatts. Then it skips medium, so don't pick medium. When I ask you this multiple choice question, don't pick medium, to small. Small hydropower is anything under 30 megawatts up to 100 kilowatts. And then finally, micro hydropower is anything under 100 kilowatts. And micro hydropower are things that, because I'm pulling such a small amount of water out of the system, this is something that I would consider getting siphoned off normally. In the case of the farmers, I could even count that as water that would go towards utilization on the farm for either watering crops or, giving to my animals, so on and so forth. And so this is such a minute amount that this would be the unregulated form, but I am not allowed to hold back the water. I cannot build a dam in this case. Once I'm going to put a dam in, that's a different game. But if I'm going to do a diversion system or pump storage system, if I'm only going to produce 100 kilowatts or less, and that's a lot of power, then I'm allowed to put that system and not be federally regulated. As far as finding electricity, The gravity constant is the one that you're going to use to determine the amount of electricity. And once again, this is maximum. Your efficiency will go down. So you have to take into account the number of your efficiency. But this gives you your maximum amount of power that you can produce. And so the power would be equal to your gravity constant times your weight of water. So how much water am I holding back behind my gate, right? And then my distance and rate of fall. So how quickly will it fall down? Or another way to take it is the height of the dam times the river flow. So once again, rate of flow, and times that by efficiency and divide the whole thing by 11.8. And so you have two ways that you can determine power: Viva, electrical grid generation, and the second one takes into account efficiency right off the bat. So on that note, we have now completed information towards wind and water power. One of the topics that I haven't gone into is water turbines based on oceanic water supply. And that's because currently wave and shoreline turbine systems are just not in the wheelhouse of viability. It is something that if I was teaching this course on campus, I would still do that subject or throw it in as like a bonus information if I had time at the end of the year and we didn't lose anything to snow days. But as far as an online course goes, I'm not going to go into it. However, if you have any interest in wave turbine systems, tide turbine systems, and things, please just contact me. I'm happy to share my PowerPoints, information, and additional on these things. We have some right in the East River on the one side of New York City, right? So East River right here in New York. And so it's not like it's a new concept, but the one on the East River is only producing, I think, 50 kilowatts annually. So it's a very minor sort of semi-experimental system currently. So on that note, good luck. Once again, if you have any questions, post them in the discussion.